To Unit 3, Section 4. Today we're going to talk about the ever-important function notation. Function notation is something that you guys are going to see for the remaining part of your mathematical career. And really, it's just a fancy way of saying y, or denoting the y variable. Which, remember, y is your dependent variable. It depends on what the value of x is. So the way we express this function notation is f parentheses x, and it's read as f of x. It is a function of the independent variable x. So let's get a look at a few examples, and I think you'll see what I mean. It says here to evaluate the function x for 2x minus 7 when x is equal to 4. So the way we'd write that is f of 4 is equal to, now remember this part here just really represents y. Find out what y is when x is 4. So we're going to substitute 4 in for x and then subtract our 7. So 2 times 4 is 8. 8 minus 7 is 1. So we would say that the dependent value y is equal to 1 when x is equal to 4. And that makes the ordered pair 4, 1 a part of this function. All right, in 1b it says use the function f of x equals 3 times x squared minus 2 to find f of negative 3. All right, so in other words, find out what the output or the dependent variable is when the input or the independent variable is equal to negative 3. So we're going to write this as 3 times negative 3 squared minus 2. Following your order of operations, you have to square your negative 3 first. So that becomes 3 times 9 minus 2. 27 minus 2 is 25. So we would say f of negative 3, the function is evaluated for when x is negative 3, the result is 25, which makes the ordered pair negative 3, 25 a part of this function. All right, let's get some practice at interpreting what these functions mean. It says let f of t be the outside temperature, that's one variable, that's your dependent variable, in degrees Fahrenheit, t hours after 10 a.m. and that is your independent variable. Okay, in other words, that's your input. All right, the t hours after 10 a.m. Explain what the following means in the context of the problem. So here it says f of 0 equals 75. All right, well, my input or my independent is 0. And 0 represents t, and t represents the hours after 10 a.m. So if it's 0 hours after 10 a.m., then the time must be 10 a.m. And here it's equal to y. Or sorry, it's equal to 75. So 75 represents my outside temperature in degrees Fahrenheit. So at 10 a.m., and I'm going to write T here for temperature. Actually, I'm just going to write temperature. 75 degrees equals my temperature at 10 a.m., and that's going to be in degrees Fahrenheit. All right, so when it says f of 3 equals 100, then remember this 3 that's in parentheses represents my independent variable. All right, it is the value of t, and t we said is hours after 10 a.m. So 3 hours after 10 a.m. Well, let's see, that makes it 11, 12. That must make it 1 p.m. is the time, and the temperature here is the output. It is 100 degrees is the temperature at 10 a.m. and that's going to be 100 degrees Fahrenheit. Example 3 says g of x, here's full-on function notation, g of x is equal to 1/3 of your input x minus 2 more. Find the value of x for which g of x is negative 4. So this is a little bit tricky now. They're saying that the output is negative 4. So negative 4 is going to be substituted in for g of x is equal to 1/3 x minus 2. So now we have to solve for x. In other words, find your independent variable that produces the dependent variable of negative 4. All right, we're going to solve this like we'd solve any other equation. Start by adding 2 over to the other side. That leaves me with negative 2 is equal to 1/3 x. To get rid of that 1/3 that's in front of the x, we are going to multiply by the reciprocal of 1/3, which is 3. Multiplying the negative 2 by 3 gives me negative 6. So my input is negative 6 when my output is negative 4. So the coordinate negative 6, negative 4 would be on the graph, would be on the graph of this function. Let me erase that there. So negative 6, negative 4 would be on the graph of that function. All right, just a few more graphing examples. We're going to graph a function now, which remember is just an equation. We have inputs and outputs. Your inputs are your x values. Your outputs are your y values. Your x's go in, your f of x's, which is just another way of saying y, are the ones that come out. On a graph, you can think of this as your x-axis and your y-axis. You can also think of it as your input axis and your output axis. All right, so let's calculate what our outputs would be. If x was negative 2, I would substitute negative 2 into my equation, and that would be 3 minus a negative 2. Well, minus a negative would be plus a positive, so that's going to be an output of 5. Likewise, when I put negative 1 in for my x, I'm going to have 3 minus a negative 1. That's going to give me 4. And I'll have 3, 2, 1, and 0. All right, now we're going to plot these ordered pairs. Negative 2 over and 5 up. It's going to go right here. There we go. Negative 1 and 4, 3, and 0. Sorry, 0 and 3, not 3, 0, 0, 3. 1 over and 2 up, 2 over and 1 up, and then finally 3 over and 0 up. Now this is going to be assumed to be a linear equation here, and it will be a continuous one, so we'll just draw our line straight through those points, and then we can add arrows to indicate that that's going to keep going on and on forever. All right, one final example for today. It says to answer the following questions using the graph below. Now when we answer this question, it says to find f of 6. You have to know how to interpret this f of 6. Well, this 6 is our x value. So we're going to go over to our graph where x is equal to 6, and we're going to look up to the point that exists on the graph. Well, that point is 6 over and 7 up. And it wants to know what the output is when the input is 6. So this is basically asking you to find y when x equals 6. And the y coordinate there is going to be 7. We can see that by tracing that back over here to the y-axis. So my output, when my input is 6, my output is 7. Next it says f of x is equal to negative 3. In other words, your y value is negative 3. Find out what x is. All right, so let's go on our y-axis. Let's go down to negative 3, and we're going to trace that across to the point on the graph. So here is where we have this coordinate where y is negative 3. We want to know what the x coordinate is. Well, if we trace that back up to the x-axis, we can see that that's negative 4. So x is equal to negative 4. All right, that's our examples for today. We'll talk more about inputs and outputs and function notation later in class.